Okay, so this says an inverted pyramid is being filled with water at a constant rate of 35 cubic centimeters per second. The pyramid at the top has the shape of a square with a side length of 3 and a height of 8. So this B1 we can label as 3. This B2 is also 3, and this height is 8. So it says find the rate at which the water level is rising when the water level is 2 centimeters. So the first thing you want to do with all these related rate problems is just list all the given information that you have and then figure out what it is you're actually looking for. So this says that an inverted pyramid is being filled with water. So this water that I added to the picture is increasing. The volume of this water is increasing. So dV dt, the volume of the water with respect to time, is changing at a rate of 35 cubic centimeters per second. Okay. This pyramid at the top has dimensions of 3 by 3, and the height of the pyramid is 8 centimeters. That doesn't pertain to the water we're talking about, but we're going to use that to find some values of the water. It says find the rate at which the water level is rising. So if we call the height of the water, let's pick a different color here. The height of this water, I don't know if you can see that, we'll call that capital H. We're looking for dH dt, the height at which the water is rising when the height of the water is 2 centimeters. Let's just make sure that everything else is given in centimeters, so we're good. So once we kind of have that listed, I then need the formula that relates these values, and that's going to be the volume of a right pyramid. The volume formula for a right pyramid is 1/3 times, if these were my bases B1 and B2, it would be B1 times B2 times H. It's basically 1/3 times the area of the base times the height. But since B1 and B2 are the same because it's a square bottom, this is just going to be 1/3 times the base squared times the height, the base side. We'll just call that B and call that B. So the problem is now if I differentiate this, I will get a dV dt. I will get a dH dt. This I guess should be capital H because we're talking about this now. And we can call this capital B if we want to. But I will also get a dB dt, which I don't have. I don't have a value for dB dt because when I differentiate b squared, the result's going to give me dB dt, which they never mentioned in the problem, how fast the base is changing. So I need to get rid of the b. I need to get this b out of here because I don't have any information about dB dt. So what I can do is replace b with an equivalent expression involving h by using similar triangles. So if you kind of turned and turned this pyramid so it's facing you and you had like a triangle like this is going to be the big pyramid, and then we'll do a smaller one in blue for the water pyramid. So if I label this big pyramid, this top value is 3. It's not really perfect. And the height of it is 8, which means that the distance between the center and the edge is 1.5. I'm going to use this right triangle to come up with a relationship between the values of capital B, capital H, and these numbers. So if I look at the small pyramid, the height here is our H, and the distance from here to here is our B over 2. Let's make it even easier than that. Let's just keep this as 3, and this says B. We don't need to do base divided by 2. So we'll just keep this as 3 and B. So since these are similar triangles, I know that this side over this side should equal this side over this side. The proportions stay the same. So B over 3 equals H over 8. Okay. You could have used the 1.5 and the B over 2. You're just going to get messier numbers, that's all. So when I cross multiply, I get 8B equals 3H. Now look, I'm trying to get rid of B in my equation because I don't have a dB dt. So I'm going to solve this for B. Dividing both sides by 8, I get B equals 3/8 H. So I'm just going to take that value for B and substitute it into B into the formula for the volume. So I get the volume equals 1/3 times 3/8 H squared, because it's B squared, times H. Which, when I square this thing, I'm going to get 3 squared over 8 squared. So this is going to be, I'll put it down below actually, V equals 1/3 times 3 squared, which is 9, over 8 squared, which is 64, times H squared times H. Just to show you, we have 1 divided by 3 times 9 divided by 64. If I simplify that fraction, I get 3 over 64. So this is V equals 3 over 64 H to the third. Okay, there's my formula. It only has V's and H's now, which is good because that's what I'll have when I take the derivative. So let's take the derivative. Derivative of V is just going to be 1 dV dt. Apply the power rule, bring the 3 down. 3 times 3 is 9 divided by 64. H squared dH dt. Hey, look at that. I have dV dt. I have H. I can find dH dt. So plugging those values in, I get 35 equals 9/64 times 2 squared, which is 4 dH dt. 9 divided by 64 times 4. I do 35 divided by that. 62.22 repeating. 62.2. We'll just say 62.2. Equals dH dt. And that's your answer, 62.2.